Hey guys, this is Angela Galloway. This is Math 146, and this is a lecture on 12.3. So we're in Unit 4, about halfway through our section. So what we've covered so far is just learning about the basics of statistics. In 12.1, we learned about how to collect the data, the different types of data we have, and we looked at how to graph the data. Then in section 2, we looked at measures of central tendency. So central tendency, what we're talking about is if we've got our data here, so of course what we originally have is we've got quantitative data that we're working with, okay? So when we get our quantitative data, we put that into a histogram, right? So let's say it looks something like this. Then when I draw this curve, what I'm meaning is that that curve kind of lies on top of the histogram. So it gives me an idea of the shape of the data, okay? So the data is not actually on that curve. It's just this curve is describing what my histogram looks like, okay? So when I've got this data, the first thing I might want to know is where's the center? And that was the measures of central tendency that was in 12.2, and we looked at using the mean, median, and mode to describe the center of our distribution. Well, if you notice, if I've got that histogram and then I have, let me fill in another color that you'll be able to see. And then maybe I have another histogram that looks like this. Okay, now pretend like these lines are straight. Okay, this other histogram is centered at the same place, right? But what's the difference in this green histogram and the black histogram? Well, the difference would be the width of them, right? The green histogram, if I'm thinking of this bottom here, okay, the bottom of the graph here, this is the x-axis, right? So it starts at 0 and goes to infinity. Right? Okay, over here, my y-axis is showing either percentage, relative frequency, frequency, account, how many people or things fell into each of these groups, right? So the higher the bar, the more people or objects that fell into whatever range of data we're talking about here, right? So looking at the difference in these two graphs, the green one only goes from this number to this number, right? The black one goes from this one to this one. So I might want to know about that. Might want to know that my data goes from 10 to 20 or goes from 5 to 40. I want to know what is the range of my data, right? So that's what the measures of dispersion is going to tell us about. It's how dispersed is the data, okay? So the first way we can describe that dispersion is just looking at the range. The range is a pretty simple measurement. All we do for that is we look at the biggest number, which we call the maximum, or we shorten it and just call it the max, minus the smallest number, which is the minimum, okay, or the min that we see here. So like for the range of this black one, you would take whatever the largest number here, let's say it goes up to 60, and it starts at 10. Okay, so the range of the black would be 60 minus 10 would be 50. Now for the green, let's say that it goes from 20 to 45. Okay, so it has a range of 25. So we could know just from that that for whatever reason, the data in the green histogram is much less spread out than the data in the black histogram. So maybe if I was looking at, two tests or two quizzes or whatever that I gave, I would see that the green one, the green and the black comparatively, they centered around the same, so the average was around the same. But the green one, the students tended to do better on because it had a smaller window, right, of those grades, a smaller range. So they only went from 20 to 45 instead of 10 to 60. Okay, so they centered, or they averaged, or they were set around that average closer than what the black was doing. Okay, so the range gives us just a quick idea of where the data is. The standard deviation is a more complicated thing to calculate, but it does give us more information than just having the range does, okay? What the standard deviation is telling us is it describes how different the observations are. The larger the standard deviation is, the more variation there is in the data set, okay? Standard deviation is going to range from 0 up to infinity. Okay, so it has to be a non-negative number, 0 or a positive number. It can't be negative. The closer it is to 0, the less variation there is in your data. The closer it is to infinity, or the bigger it is, the more variation there is in your data. Now, just like we did with means, we do have two different ways of calculating standard deviation, okay? Population standard deviation is our standard deviation that we would calculate from population data. Okay, so like if we were dealing with census data or some sort of data that included everybody from the population, we would be calculating a population standard deviation. To calculate that, first we calculate mu because that is in the formula. Remember, mu is our population mean. We take each of the observations and subtract the mean. We square that difference. We add all those squared differences up and divide by big N, which is our population size, or the size of our population there. And then we take the square root of that. Okay, and so that gives us our standard deviation for the population. That is represented with this Greek letter sigma. Remember I said that usually our parameters have Greek letters. Our statistics usually don't. So for the sample standard deviation, we represent that with just a lowercase s. And you see we pretty much do the same thing. Of course, we're using an x bar here because we're coming from the sample. So we want to have a mu anymore. We'd have an x bar. We do the same operation. The only thing that's a little different is that we divide by n minus 1 instead of n. And that's because we're dealing with a sample and not a population. And I don't go too far into why that's true, but that is the reason. Okay, so for that reason, when you're calculating sigma and s, or when your calculator is calculating it, they're going to be pretty close to the same number. Okay, it's only going to be a little different because for sample standard deviation, you're dividing by n minus 1 instead of n. So the sample standard deviation is always going to be larger than the population standard deviation when you look at it in your calculator. Okay, now sometimes that formula can be a little scary, okay? So what we're going to do first is just look at thinking of standard deviation, just the concept of it, okay? So before we even learn how to calculate it, let's just see if we can figure out what standard deviation is telling us, okay? So I've got these three different standard deviations here, 0, 4, and 150. And I want to see if we can match them to which data set they might represent. Okay, so without calculating it. So the first one we're going to look at is S equal to 0. So the standard deviation is equal to 0. Which one of these data sets has a standard deviation equal to 0? On number 2. Okay, so we're going to put the standard deviation of 0 with this, okay? Now, why is this a standard deviation of 0? Well, remember, standard deviation tells us how different our observations are, right? How much they vary. If they don't vary at all, like this data set, I mean, that would be a strange data set, but it's possible. You know, you got a data set where all of them are the same, then the standard deviation is going to be 0 because there's no difference in each of the observations, okay? So what that tells us is the closer that our standard deviation is to 0, the less our observations in our data set vary. Okay, so if you see your data set and the numbers do not vary very much, okay, if they're all pretty close to each other, then you should expect a small standard deviation when you calculate it, okay? So now we've taken care of this one. Now we've got a standard deviation of 4 and 150 to choose between. So looking at these two data sets, which one would the 150 go with? Well, probably this one down here, right? Because you see that these numbers vary pretty a lot, right? Because we go from 6 to 98 to 221 to 350. There's a big difference in those numbers, right? So they're going to have a large standard deviation. And so that's our standard deviation there. And then the last one we have left over is 4. And looking at this data set, 4 makes sense, right? These don't vary a lot. We've got 5, 8, 11, 13, and 15. They do vary a little, right? They're not exactly the same, but they definitely don't vary as much as something like this, right? So 4 probably makes sense. And so that's how we would just be able to match our standard deviations. Now, what about if I'm looking at this? I guess I should have erased these first. But that's okay. You're probably looking at the notes that already have the answers on it anyway. But looking at these two data sets, which of these data sets has a larger standard deviation? So you'll notice that, they're both centered, these are written in order, smallest to largest. So they're both centered around 50, okay, or have a mean of 50. But what's different is the range of data, so how the observations differ. So does data set 1 or data set 2 have a larger standard deviation? It would be data set 2. And the way we can see that is these data points differ much more than these do. This, even just looking at the range, this one goes from 41 to 66. This goes from 20 to 70. So obviously these are going to have more of a difference than these do. So data set 2 would have a larger standard deviation. Okay, the last example is which one of these has a larger standard deviation? You notice they're all centered at 4. Okay, so remember this is just a curve that kind of describes what our histogram would look like underneath here. So which one of these looks like it has the largest standard deviation? This can be a little trickier because sometimes when we're looking on the graph, we don't really know what we're looking for, okay? But when we're thinking about the data being more spread out, okay, when the data is centered around the same spot, but it's more variable, what we get is that this high curve gets pushed down, gets flattened so that it can account for the data that has spread out. Okay, so the data is more spread out. So this blue one here, the blue is going to be the one with the highest standard deviation because you'll notice the blue extends the farthest here. It's got the most data out in these tails here. Okay, so as it gets shorter and gets pushed down there, it's expanding on either side to allow for whatever data points may be falling farther away from the mean than some of these other ones have. Okay, so the flatter the curve, the more spread out it is. So green, the green one up here, would have the smallest standard deviation because it's the narrowest, so most of the data is more centered around the 4. Okay? All right, so now let's get to actually calculating it. What I want to make clear in this section is I do not really expect you to do standard deviation by hand. Okay, now if you want to do it that way, that's fine. That's why I'm going to go through an example and kind of show you how you would do it by hand. However, then I'm going to show you how to do it on your calculator or do it using Excel. Okay, now if you're taking this class as a lecture class, on our test and things like that, you'll only have your calculator. You wouldn't be able to use Excel, but we probably won't have any problems where you have to work out the standard deviation um, with the formula. You'll be doing more of matching and that kind of stuff. If you're taking this as an online class, you do have access to use Excel while you're doing your test, or you can use your calculator. So there might be some problems where you have to calculate standard deviation. Okay, now all of them should be fairly small data sets, so it shouldn't be something that's going to be real labor intensive if you did do it by hand. But if it's at all possible, I would strongly encourage you either to get the graphing calculator and be working on that, so the TI-83 or better, or to learn how to use Excel, okay, for these type of problems. So let's look at this small data set. We've got 2, 5, 7, 8, 12, and 14, and we're going to calculate the standard deviation. Now this here is the formula that we are working with. Okay, so this is our standard deviation formula. Now remember, you don't have to memorize any formulas. All these formulas are given to you for your test or your final exam or whatever. You just need to know how to use them, right? So what this formula tells us is, first of all, it tells us we need the mean, right? Because it has x bar in there. So the first step here is just calculating the mean. So x bar equals add up all the observations, divide by n. So we did that. 48 divided by 6 gives us 8. Okay, now it says we need to take that mean and subtract it from all the observations. So these x sub i's are just each individual observation here. So what I did was I kind of just created a chart because we're going to do these in steps. So the first step is just rewrite your data from up here. Okay, so I've got 2, 5, 7, 8, 12, and 14. Those are each of my x sub i's, okay? Next, what I'm going to do in the formula, it says take each of those x's and subtract the mean. So that's what I'm going to do. 2 minus 8, 5 minus 8, 7 minus 8, 8 minus 8. Okay, so I did that all the way down here and I got these answers. The next step, it says over here in the formula, is to square all those differences, right? So I'm going to take each of these differences and square them. So negative 6 squared is 36. Negative 3 squared is 9, etc. Okay? So once I get to this column, all my answers should be positive at this point, right? Because I've just squared either negatives or positives. Either way, I get a positive. Okay, so I go all the way down here. I've done all this. This tells me I need to add up, right? That's the summation symbol. It tells me I need to add up all those squared differences. Okay, so that's what I did here. I added up all these numbers and I got 98. Okay, once I did that, that 98 is this. Okay, so what all this work we've done here was just to get the numerator inside that square root. Okay. So now that I've got that, I see, well, what's n? N is my sample size. I have 6 observations, so that's my sample size. So I plug in a 6 minus 1, because that's in the formula. I do 98 divided by 5, which is 19.6, and then I take the square root. And I get about 4.43. And that is going to be my standard deviation. So obviously for a large data set, this would take a lot of time to do by hand. Even for a small data set, it can be difficult for students. And that's why I'm recommending that you don't do it by hand if at all possible. So if we don't do it by hand, how do we do it in the calculator? Well, this definitely, if you have the graphing calculator, this is going to be your best friend, or at least I think so. This is one of the best functions that we have in our calculator. Okay, so what we're going to do is the one variable stats procedure. Okay, so if you need more help on it, if this example doesn't help you enough, I would go to YouTube and type in one variable stats. Okay, and you will get lots of different videos of examples of how to use it or different problems showing people use it, because you know, you can, whatever command you're using in your calculator, if you type that into Google or YouTube or whatever, you're going to get a lot of info on how to use it because lots of people have made videos or made tutorials on how to use it. All right, so what we're going to do is we're going to put in our data from our last example. So we want to go to Stat and Edit. That's where you always go if you're wanting to put in data. Okay, so if you have data to put in your calculator, you do Stat and Edit. Okay, now you should see your list in your calculator. If you've already got data in here, let's say I have some old data here, okay, that I want to get rid of. The easiest way to clear that out is just to go up to the list that you want to clear out. So make sure it's highlighted up there, push clear, and then enter. And that'll clear out the whole list so you don't have to go through and delete each item in there. Okay, so now I've got a clear list and I'm going to put in my data. So I've got 2, 5, and you just push enter after each number and it goes down to the next line. Okay, so now there's my data, 2, 5, 7, 8, 12, and 14. All right, once you've typed it in, it's saved in there. You don't have to push save or anything. It's already going to be saved in that list 1. So we're going to go back to Stat, and now we're going to Calculate. And we're going to do this very first thing here, the one variable stats. Okay, now on my calculator, this one here that I'm showing you, it doesn't have any prompts that tells you what to put in. It's possible your calculator might say, it might have a prompt, that says, where's your data, and you put in that blah, blah, blah. But if it doesn't, if it looks like this, all you need to tell it is, where's your data? Our data is in list 1, or where I put mine. So I do the second and 1 because all these yellow ones here, see, those are all the list for our data. So mine was in L1, so I chose the L1. If yours has a prompt, you just want to put L1 for the data, and then for the frequency list, you just want to make sure that's blank because we don't have a frequency for ours, okay, and then that will be it. Okay, and then you push enter. All right, now this is going to output a lot of information, okay? So we've got the one variable stats here. It gives us the mean, which is nice. Okay, so we have the mean. It gives us a few things that we don't really use, but they're used in a lot of statistical formulas, so they just give them to you in case you might need them. The sum of the x's, the sum of the x's squared. Then you notice here, let me move this over here. Right here we've got S sub x and sigma sub x. So what do you think those are? Well, those are our standard deviations, right? This S sub x is our sample standard deviation. This is our population standard deviation. Now, almost always in this class, we will use the S sub x, okay, because we're almost always working with sample data. The only time you would use the sigma is if for some reason they specifically said in your question, this is a population. We want you to calculate the population standard deviation. But as far as I know, most of our problems ask for sample standard deviation. Okay, we're usually working with a sample. So we'll use that S sub x there. Okay, and so you notice they're very close. The numbers are very close, so you can't necessarily look at it and know which one's right to use because they're both going to look fairly close because the formulas are so similar. But we want to use the S sub x, okay? Now notice there's a little arrow here. That means there's more information. So if we arrow down here, so I'm just pushing the arrow button down, I get more numbers down here. So notice I get the median here, which we've talked about already, the 7.5. These other numbers are something that we call the 5-number summary that we're going to get to later on, but those will be important later as well. And so you can just scroll up and down until you type in something else in your calculator. You can do that with this. Okay, so you see we get the sample standard deviation is 4.43. If we go back here, 4.43 is what we got by hand. So that's how you can do it both ways. Okay, another thing you can do is you could do it in Excel. So if you don't have the calculator, you can still do it in Excel. Okay, so it actually is kind of convenient doing it in Excel because our homework is already set up where you can copy your data straight into Excel. Okay, so this is from our 12.3 homework. This one says compute the range and sample standard deviation. So notice it says sample standard deviation. So that means the S, not the sigma, right? For the strength of concrete here. Okay. So whenever you have a data set in your MyLabs, you'll notice this little blue box over here, and it says click to copy table when you hover over it. If I click on it, I can say open in Excel. So if I click that, and then you might have to say, yes, I want to open it. Then your data comes up here, okay? So that saves you time because then you don't have to type in all the data. You don't have to worry about typing in something wrong because it's all there for you, okay? Now that we have the data, how could I find the standard deviation? Well, the quick way would be if you just want to know the standard deviation, you just go to any cell here, any of these boxes, okay? If you want to type in a formula in Excel, you always start with equals, okay? So I want this to figure out the standard deviation. So if I start typing ST, as soon as I get to that, you notice all these that say look like standard deviation, right? So if I do STDEV, okay, that is the standard deviation. Now you still you see this one, it says standard deviation dot S. It says it estimates standard deviation based on a sample. Actually, the STDEV is good enough, but you could use this if you want. So the STDEV dot S, and then highlight all these numbers, put a parenthesis around it, and push enter. And there's our sample standard deviation, okay? If you wanted to know the range, I assume will it do the range? It may not do the range, but what it will do is it will give you the minimum and the maximum number if you didn't want to pick it out on your own. You do the minimum, which is MIN, and the maximum, which is MAX. And so there's my minimum and my maximum number. So now to find the range, I just do equals this number minus that number. Okay, so my range would be 1210. So let's go back here and make sure so you can see that we're doing this correctly. The sample standard deviation, it said, was, what's it say? Round to 1 decimal place. So 489.5. Okay, and so that's how we would do that. All right, we also could put this in our calculator and we'll get the same answer. But if you don't have the calculator, or if you want to use Excel, you can do that. The other thing you could do, which I also talked about in the histogram video, if you're needing to find like the standard deviation and the mean and the median and all that stuff at the same time, you can use your data analysis tool. If you don't know how to add that in, you go over to File, Options, Add-ins. Okay, then you get this screen here. You want to go down here to Manage Add-ins, do the Go there. And then you see mine's already checked. But if yours is not showing, it won't be checked. So you just check it and push OK. And then it will show up there. Okay, so when I click on the data analysis, so this is in the data menu, data analysis, do descriptive statistics. I'm going to do my input range as your data. Okay, so where's your data? So make sure your cursor's right here and then highlight your data. Then we want to go to output range. So where do you want all your output of your mean and median and all that? So put your cursor in there and then just click anywhere. That's where the output's going to come. And then put the summary statistics because that's what we want to get. And then OK. And then you see it gives us all this information. So we have the mean, we have the standard deviation. We have some things that we don't really use. The median we use. It does give the range there. The minimum, the maximum, the sum, if you need that, all that. We don't use these or this, okay? But everything else we do use. This one actually even gives the mode. In your calculator, it doesn't do mode. I guess because they figure you can kind of just look and figure that one out, but it doesn't do mode in our calculator. So you can, find the mode this way too. Okay? All right, so that's how you would do that if you wanted to do it in Excel. And I do think that's helpful to do in Excel because you've already got this nice little thing where you can just copy it straight into the table. And that makes it a little easier. Okay, so now that we have learned about some statistics and parameters, let's just look at and summarize what we've talked about. So for our sample data, when we collect the data, two of the things we figured out we could calculate are X bar and S. Okay, so these would both be considered statistics because they are numerical summaries that come from the sample, right? Now we use these numerical summaries from the sample, so we use these statistics to infer about the population parameters. The population parameters that we talked about are mu and sigma. Okay, so we will use our X bar to infer about mu. Okay, so that's just a quick summary of what we've learned, some of the things we've gone over so far. So just looking at which one of these variables were stats and which ones were parameters. Okay, so I'm going to stop this video here. I will continue in 12.3 in another video because I think this one probably has already given you enough information. Remember, if you have any questions, you can always email me at angela.galloway@kctcs.edu.